Hello dears, how is your time going? This is part 6 of matrix and determinant series. In this part, we will solve a problem that will help us to explore all the possible operations in matrix, that's addition, subtraction, and multiplication of matrices. Here is a question. Let's say equal to a 3 by 3 matrix with elements of first row 3, 1, 0, elements of second row -1, 0, 1, and elements of third row 2, 4, 5. D equal to this 2 by 3 matrix with elements -1, 1, 2, -2, and -3, 0. E equal to again 3 by 3 matrix with elements 5, 6, 1 in row 1, 4, 3, 2 in row 2, and 1, 0, -1 in row 3. And F equal to this 2 by 3 matrix with first row entries 0, 4, second row entries -2, -1, and third row entries 4, 2. Then the question is calculate BA and AB given that matrix A equal to matrix C minus matrix E and matrix B equal to matrix F plus twice of matrix D. The two matrices we are asked to multiply are given as the sum and difference of other matrices. Thus, before going to multiply them, we have to solve the individual matrices. That's matrix A equal to matrix C minus matrix E. It's given that matrix C is this 3 by 3 matrix minus matrix E is again this 3 by 3 matrix. As we discussed in part 4 of matrix and determinant series, matrix subtraction goes in such a way that each element of the second matrix has to be subtracted from the corresponding elements of the first matrix. The other requirement for the two matrices to subtract each other is they have to be similar orders. The orders of both matrix C and matrix E are 3 by 3. Because they have 3 rows and 3 columns, so they can subtract each other. So the subtraction goes on in such a way that row 1, column 1 of matrix C, that's 3, minus row 1, column 1 of matrix E, that's 5. Row 1, column 2 of matrix C, that's 1, minus row 1, column 2 of matrix E, that's 6. Row 1, column 3 of matrix C, that's 0, minus row 1, column 3 of matrix E, that's 1. Following the same pattern, we can subtract row 2 entities as -1 minus 4, 0 minus 3, 1 minus 2, and for row 3 elements, 2 minus 1, 4 minus 0, and 5 minus -1. Now, what left is simple subtraction. That's 3 minus 5 equal to -2, 1 minus 6 equal to -5, 0 minus 1 equal to -1, -1 minus 4 gives us -5, 0 minus 3 equal to -3, 1 minus 2 is -1, 2 minus 1 is 1, 4 minus 0 is 4, and 5 minus -1 means 5 plus 1 because negative times negative gives us positive. So 5 plus 1 equal to 6. Therefore, matrix A is this 3 by 3 matrix. When we move to matrix B, that's given by the formula F plus 2D. F is this 2 by 3 matrix which is given above, and 2D means 2 times matrix D, which is equal to matrix F plus this 2 outside the square bracket multiplies each entity inside the square bracket. That's 2 times -1 is equal to -2, 2 times 1 equal to 2, 2 times 2 equal to 4, 2 times -2 equal to -4, 2 times -3 equal to -6, and 2 times 0 equal to 0. Just like subtraction of matrices, addition of two matrices goes in such a way that each element of first matrix is added to the corresponding element of second matrix. That's row 1, column 1 of matrix F, that's 0, plus row 1, column 1 of 2D, that's -2. Row 1, column 2 of F, that's 4, plus row 1, column 2 of 2D, that's 2. By the same analogy, row 2 and row 3 elements can be added as -2 plus 4, -1 plus -4, 4 plus -6, and 2 plus 0. 0 plus -2 equal to -2, 4 plus 2 equal to 6, -2 plus 4 equal to 2, -1 plus -4 equal to -5, 4 plus -6 equal to -2, and 2 plus 0 equal to 2. Matrix B is this 3 by 2 matrix. Therefore, the two matrices are A equal to this 3 by 3 matrix and B equal to this 3 by 2 matrix. Now, we can multiply the two matrices if they are in the order to be multiplied. Let's start with AB, which is equal to A times B. The order of matrix A is 3 by 3 because it has 3 rows and 3 columns. and order is expressed as row by column. Matrix B has 3 rows and 2 columns, so its order is 3 by 2. Since the number of columns of the first matrix is equal to the number of rows of the second matrix, we are allowed to multiply these two matrices, because as we discussed in part 5 of this series, multiplying two matrices is possible only when the number of columns of the first matrix is equal to the number of rows of the second matrix. Matrix multiplication is a row by column multiplication, meaning each row of the first matrix multiplies every column of the second matrix, and the multiplication goes in such a manner that first element of a row multiplies first element of a column, second element of a row multiplies second element of a column, third element of the row multiplies third element of a column, and finally these products will be added. So for row 1, column 1 of AB equal to -2 times -2 plus -5 times 2 plus -1 times -2. For row 1, column 2, -2 times 6 plus -5 times -5 plus -1 times 2. As we can observe here, row 1 of A multiplies both column 1 of B and column 2 of B. The same is true for the next rows of A. For row 2, column 1, that's row 2 of matrix A times column 1 of matrix B equal to -5 times -2 plus -3 times 2 plus -1 times -2. Row 2 of A times column 2 of B equal to -5 times 6 plus -3 times -5 plus -1 times 2. In moving to row 3 of matrix A, row 3 of matrix A times column 1 of matrix B equal to 1 times -2 plus 4 times 2 plus 6 times -2. Row 3 of matrix A times column 2 of matrix B equal to 1 times 6 plus 4 times -5 plus 6 times 2. -2 times -2 equal to 4 plus -5 times 2 equal to -10 plus -1 times -2 gives us 2. -2 times 6 equal to -12 plus -5 times -5 equal to 25 plus -1 times 2 gives us -2. -5 times -2 gives us 10 plus -3 times 2 equal to -6 plus -1 times -2 equal to 2. -5 times 6 equal to -30 plus -3 times -5 equal to 15 plus -1 times 2 equal to -2. 1 times -2 equal to -2 plus 4 times 2 equal to 8 plus 6 times -2 equal to -12. 1 times 6 equal to 6 plus 4 times -5 equal to -20 plus 6 times 2 equal to 12. 4 plus -10 is -6. -6 plus 2 equal to -4. -12 plus 25 equal to 13. 13 plus -2 equal to 11. 10 plus -6 equal to 4. 4 plus 2 gives us 6. -30 plus 15 equal to -15. -15 plus -2 equal to -17. -2 plus 8 equal to 6. 6 plus -12 equal to -6. 6 plus -20 equal to -14. -14 plus 12 equal to -2. AB has 3 rows which are derived from the number of rows of the first matrix, that's matrix A, and 2 columns which are derived from the number of columns of the second matrix, that's matrix B. So the order of AB is 3 by 2. Let's move to calculate BA. Matrix B has 3 rows and 2 columns, so its order is 3 by 2. The second matrix, that's matrix A, has 3 rows and 3 columns, so its order is 3 by 3. The number of columns of the first matrix is not equal to the number of rows of the second matrix. Thus, multiplication of these two matrices with this order is impossible. In other words, BA doesn't exist. By this, I conclude this section. Please subscribe, like, and share the page. Goodbye for now.